Welcome, everyone. We'll give a couple minutes for everyone to get settled into the Zoom.
Thank you.
I'm going to spotlight our jurors as well as myself and Audrey so you guys can see us the whole time. All right, we'll give everyone a couple more minutes to see if there's any stragglers coming in. We'll get started around 10:03.
Will I be able to share?
Yes, you'll be able to share your screen during your presentation. All right, so let's go ahead and get started. This is our second day of the Retrofit Housing presentations for the Solar Decathlon Design Challenge semifinals. So here's just another quick overview of the schedule. Yesterday we had the first round of division presentations. Today we've got a few more. After this, the jurors will deliberate and select the finalist teams. And then at 2 p.m. Eastern, there's going to be a big Zoom where everyone can join, and we're going to be announcing all of the teams from all divisions that will be going on to the finals. So just a few housekeeping items. I'm sure you guys have all done Zoom before at this point, but we'll ask you to stay on mute and keep your video off while you're not presenting so that we can highlight the students who are presenting at that time. Each presentation will be 8 minutes, followed by a 5-minute Q&A period. My colleague Audrey here is going to be the timekeeper, and she'll be changing her Zoom background to give a 2-minute warning and then a time's up. So we'll give you a little example of that right now. So we'll have, the 2-minute warning, and then there'll be a time's up one at the end. So just keep in mind your time, and you can watch Audrey's screen to see where you are. And then finally, if you have any technical issues, feel free to use the chat box. We'll be monitoring that throughout the presentations, so you can send questions there. So now I want to introduce our two jurors that we have here, Michael and Stephen. Michael Ihe-Siaba is the Director of Engineering at Elevate, a nonprofit organization that designs and implements programs that reduce costs, protect people and the environment, and ensure the benefits of the clean energy economy reach those who need them most. In this role, Michael leads Elevate's engineering team in supporting the organization's engineering and technical expertise needs. The engineering team conducts energy assessments, conducts energy modeling, and provides technical consulting for Elevate's programs, projects, and utility programs that deliver services to a wide range of buildings, including commercial, nonprofit, multifamily, and public buildings. Prior to joining Elevate, Michael held senior roles with the energy efficiency and sustainability sectors for consulting companies and the utilities Consolidated Edison in New York and National Grid in New York. Michael holds a Bachelor of Science degree in mechanical engineering from the Grove School of Engineering in New York and an MBA from the Neil Griffin College of Business in Arkansas. And then we have Stephen Michael Wilder is an architect and entrepreneur from Harlem, New York, with 20 years of experience working in the built environment. Stephen is a very ambitious person who is rooted in creativity and the desire to be innovative in new and existing spaces. Stephen is dedicated to using his status, resources, and influence to better his community and other similar communities. For the last 10 years, Stephen has worked on building his architectural firm, Think Wilder Architecture. In the competitive and detail-oriented industry of architecture, there is not a day where Stephen is not juggling business, creativity, and technology. Stephen plans to use his business and architecture as a platform to help change the way underserved people live, work, and play. He has professional affiliations with the National Organization of Minority Architects, or NOMA, and the American Institute of Architects, or AIA. Stephen has a master's degree in Science of Architecture from Carnegie Mellon University and a bachelor's degree in architecture from Howard University. And then finally, we just want to thank our Solar Decathlon sponsors, which you can see here. So we just want to give a little shout out. And with that, I think we can get started with our first team, which is Illinois Institute of Technology. So the students from that university can come on camera and we'll spotlight you.
Hi.
All right, perfect. Let me spotlight your camera. All right, is it just you guys that will be?
Mhm.
Okay. Sounds
So
good.
we share a screen.
Yeah, you'll share your screen. We do have a couple minutes, but since you guys are here, I think we can go ahead and get started. So we'll start our 8-minute clock for the presentation whenever you guys start, and then we'll continue with the Q&A period directly after that. So
Okay, can you guys see my screen?
yes.
Okay. Hello, my name is Muntaha.
And my name's Ramisha.
And we're the Retrofit team from Illinois Institute of Technology. Here you can see an overview of the house in its current state on the left and the rendering of our design on the right. Our team is made up of 9 students, and we would also like to acknowledge the students who helped us with the project in the fall. Our aim for this project is to not only make the retrofitted house net zero energy, but also to make it deeply affordable. This is a goal in collaboration with the Housing Equity Initiative, or HEI, a program that is run by Sunshine Gospel Ministries. HEI's mission is to promote homeownership in the Woodlawn neighborhood on the south side of Chicago, a predominantly Black community that has been historically marginalized, and they own the house they're working to retrofit. It is important to note that the median income in Woodlawn is only about $33,000. Black families in Chicago are less likely to own homes than white families, and only 24% of Woodlawn residents are homeowners. These stats emphasize the importance of HEI's mission and the need for deeply affordable homes in this community. This map shows our site in its neighborhood context. You can see the house pinned in red. It is within a half-mile radius of a CTA train station, making it easily accessible by public transportation. Significant development in the neighborhood, such as the construction of the Obama Presidential Center that is highlighted in purple, is leading to gentrification and a significant increase in housing costs for local residents. Zooming into the house itself, you can see the digital twin we created from LiDAR scans taken during our first site visit. The house is 2,000 square feet with 3 floors and 2 units. The main unit is highlighted in yellow and the garden unit is highlighted in green. Another prominent feature of the house are the extensions that were added to the front and the back. Zooming in even further, you can see the exterior conditions of the house. The house is in a major state of disrepair and has different sidings that were layered on top of each other over the years. The varying wall types of the garden unit, the varying wall types and construction methods we discovered led us to nickname the house Frankenstein. When we went inside, we discovered that the interior of the house was not in any better condition than the exterior. The plumbing was stolen, and during our second site visit, we discovered mold growing on the walls of the garden unit. Additionally, the attic was only 6 feet tall, even at its highest point, falling short of the code requirements. This diagram demonstrates how our massing compares to the existing structure. We aim to use the existing timber framework stripped of the existing enclosure. Our intent is also to extend the back of the house to increase living space. This will bring us to a new area of 3,000 square feet. This next diagram details all of our new changes. A demonstrates the lifting of the roof, and B demonstrates the extension of the house. With C, we depict how we optimize the angle and the shape of the roof for maximum PV electricity generation. The angle chosen was 32.2 degrees because it is the optimal angle for receiving sunlight in Chicago. D shows how we removed massing to create space for skylights that would improve daylighting. Lastly, E demonstrates how we removed the front facade from the garden unit to open up the entrance. The aim of our design is to maintain both units. The garden unit we will have 2 bedrooms, while the main unit will have 3. The diagrams on the left demonstrate our program layout. The darker shades depict social areas, which we kept close to the street or the backyard, while lighter shades depict personal spaces, which were kept in the interiors. The garden unit opens up to the backyard, creating easy access between the kitchen and the backyard for social activities. It is also important to mention that we kept the bathrooms in the same spot in order to utilize the existing plumbing infrastructure. The first floor of the main unit consists of the social activity spaces, such as the living room and kitchen. We kept the original open floor concept for the layout. The extension of the house allowed us to create an extra room that could be used as an office or a guest bedroom. The attic currently exists as an empty open space, but in our proposal, we plan to put all 3 bedrooms in the attic. These bedrooms are larger than any of the existing ones. Here you can also see the skylights for the lower floors.
This model shows the current enclosure. The different colors each represent a different wall and roof type. The areas in blue and purple have no insulation at all, so the wall has an R value of 6.1 and the roof has an R value of 7.6. In our proposed design, the wall R value increases to 34 and the roof R value increases to 42. These assemblies were designed using a three-step process. The first step was to use Sapphire to generate response curves. Because our building is intended to be deeply affordable, we wanted to be selective with where we spent money. These curves helped us determine which aspects of the building have the biggest effect on EUI and when we would see diminishing returns. Based on the curves produced, we had a target R value of 35 for the wall assembly and 40 for the roof assembly. We also found that our EUI was highly responsive to the window to wall ratio, and we decided to target a ratio of 0.14 to ensure that the daylight requirements were met. The second step was to design assemblies that reach our target R values. Since we want to design a truly green building, the third step of our process was to compare insulation materials based on their R value per inch and their global warming potential. The options highlighted in green were the ones with the lowest GWP that would still allow us to reach our target R values. Since the GWP of cellulose assemblies were significantly less, we went with cellulose. Here are some additional response curves. We have decided that the increased cost of constructing a very tight building with highly efficient windows will be worth the gain in energy savings. In our proposed design, we are significantly increasing the amount of daylight reaching each level and fully meeting the luminance criteria. We are able to accomplish this by increasing our window to wall ratio and using skylights. The Sapphire energy model determined a 3-ton cooling load. We will provide separate HVAC systems for each unit. The load is 2 tons for the main unit and 1 ton for the garden unit. The heating load is approximately 27 MBH. We believe that we can meet these loads through either a VRF, multi-split, or Minitere system. The energy analysis resulted in an EUI of 24.5 kV2 per square foot per year. The table shows the current inputs for a Sapphire model. Approximately 50% of our energy use is from lighting and equipment loads. Our final lighting design will have a lower lighting power density, resulting in additional energy savings. Our roof PV system consists of 43 modules and 2 inverters. It's estimated to produce 21.72 megawatt hours annually, exceeding our proposed EUI. Our HERS score of 47 is prior to renewable energy generation. We will continue to refine our inputs to improve the accuracy of this estimate. To summarize, the monthly energy use graph shows the original building in blue and the retrofit building in red. The green line shows the potential energy generation of the site. As you can see, the building will generate excess energy in the summer and will be in deficit in the winter, but on an annual basis, it'll be slightly net positive. To be deeply affordable, we developed 3 models for our budget. Strategy 1 is the most cost-effective at $114 per square foot. Strategy 2 increases the cost to $144 per square foot for a net zero ready home with garden and back porch areas. And strategy 3 includes the cost of a PV system to achieve net zero status, and this only raises the cost to $159 per square foot. To offset the construction cost, we'll pursue subsidies and rebates. This will help us reach a lower limit target of $90 per square foot for the sale price of the home. Promising programs include the Justice 40 government initiative, which offers federal investments in affordable and sustainable housing for marginalized communities. Another is the IRA rebate, which focuses on net zero energy construction and provides additional funding for retrofits. Obtaining these cost reductions will help us to achieve our goal of being deeply affordable so that our net zero energy retrofit better serves the community.
Thank
Thank
you.
you.
All right, thank you so much, Illinois Institute of Technology. And we will get started with our Q&A. You guys are free to use your slides to answer questions in the Q&A. And so I'll pass it over to the jurors, and there is 5 minutes total.
All right, I could go first for this one, Stephen. Thank you for the presentation. Very good job. Can you go back to the HVAC plan that you had, the slide? Great. So you mentioned that you're going to be adding to the building. Are you proposing new HVAC units for the entire building, or is this just for the addition?
So this will be for the entire building, but we'll be having a separate HVAC unit for each unit, since there's 2 units in the house.
Okay, so this is just for cooling, or do you plan on utilizing the existing gas infrastructure for heating, space heating and water heating?
We're definitely trying to electrify the whole home. So we'll be using not the existing infrastructure, but introducing the new HVAC system.
So are you, yeah, go ahead, finish.
Oh, I was just saying that it's currently gas, so we want to introduce new HVAC options.
Got it. So are you going to be introducing a new way of heating the water? So maybe a heat pump water heater or so forth?
Yeah, we were looking into using a heat pump water heater, but our options are just not finalized right now, but that is definitely something we're looking into.
All right, Stephen, there you go.
Thanks, Michael. Good morning, everyone. Great job on your presentation. I wanted to know what is the average cost of construction in the area of Chicago right now where this home is?
It's around like 200 something, right?
Yeah, I think,
Per square foot.
yes, it's a little bit higher than, it's like maybe $300 to $400 per square foot.
Okay, and so is that, and I know you guys also mentioned that the area is subject to or is experiencing gentrification, and so you guys have considered that as well in terms of being able to bring that number down to $90 per square foot.
Yes. Mhm.
Okay, great. And so when you guys were deciding on your building extensions and increasing the building envelope and the overall size of the building, how much of a role did the building code and zoning play in those decisions?
So the building or the zoning area that the house is in doesn't have a maximum height for the houses. And the house that as it currently exists was already at a lower height than the rest of the houses in the area. So by us raising the roof, we're not really breaking any of the zoning laws because we're bringing it back up to the maximum height that it could go to. So we looked at the zoning codes, but it wasn't really affecting any of the design decisions that we were making. Yes.
Okay, and what were some of your strategies? I'm not sure if I caught it or not, but what were some of your strategies on creating a more comprehensive building envelope with the various types of exterior materials, the cladding that was there that you showed?
Oh, so we decided that we want to preserve
The structure.
Yeah, we wanted to preserve the structure, but the materials inside can't really be preserved. They are pretty old and they have mold growing in them, so a lot of it can't be preserved. However, we do want the house to look like it belongs in the neighborhood. So in our rendering here, we're still keeping the overall look of the neighborhood in with the siding that we're choosing to represent in the house.
Okay, all right, Michael.
Yes, did you show a timeline for completion?
No, we did not.
Got it, okay. When do you think, if you were able to start the project, when do you think this can be completed? And how much time?
We did have an estimate from Michael, right, with the design build, I mean, from Paul.
Yes, I think, was it 3 years?
I feel like it was less than 3 years.
I think it was a max of 3 years when we were looking into it.
Okay, and it's not currently occupied, right? The
No,
home?
it's not. It's not currently occupied.
Got it. That's all I have. Thank you.
Thank you.
All right, that concludes our 5 minutes. So thank you so much to this team. And we will move along with Howard University next. So anyone from Howard who's going to be presenting can turn on their cameras and I'll spotlight you.
Okay, I'll share my screen now.
Perfect. Okay. Give me one more minute to spotlight the rest of you guys. Okay. Guess there's a limit on how many people I can spotlight, but you guys should all be at the top of the video screen. So we are a few minutes early, but are all of you guys here and ready to present? All right.
Yes, ma'am.
Then you guys can go ahead and get started and we'll start our 8-minute clock.
All right, thank you. Good morning, everyone. Today, our group Retro Booming will present our approach to retrofitting the historic Mary Church Terrell House. Here's the team. We see retro booming as a means to add prosperity and efficiency to an existing structure while preserving its historical legacy. Our design goals consist of three main objectives: legacy, equity, and net zero and decarbonization. For context, the Mary Church Terrell House is located in Washington, D.C. in the LaDroit Park Historic District. It is a 15-minute walk away from our Howard University campus. Here we've noticed several building characteristics. The Mary Church Terrell House is a narrow 3.5-story house defined by its Victorian-style architecture and features distinct window bays along the first and second stories. The flat western facade of the house is a firewall which saved the house as we know it from fully being destroyed during a fire in the 70s. Here we've included daylight studies for our site that showcase its orientation to the sun and how light enters the building at different solstice points. Our PV panels we are placing in the backyard pergola will receive optimal sunlight throughout each solstice.
Mary Eliza Church Terrell was an African-American educator, civil rights activist, and writer who was one of the first Black women to receive a master's degree. In 1909, Terrell was among the founders of the NAACP. During her residence, this house hosted a distinguished social network of prominent Black educators and public figures who lived in the affluent LaDroit Park neighborhood. Her life's work focused on the notion of racial uplift, the belief that African Americans would help end racial discrimination by advancing themselves through education, community activism, and the motto, lifting as we climb.
Here's the timeline of Mary Church Terrell's history in connection to the house. She only lived on T Street from 1899 to 1913, and by the 1970s, the other half burned down, the Terrell's house being saved by the Western Firewall. The last repairs were done in 2009, and in 2018, Howard received a grant to preserve the civil rights legacy.
So here we dictated the nature of the house as is. It comprises of all residential spaces. And here is our proposed program. While we intend to continue to provide residential accommodations to the house, we thought this project could also be a great opportunity to be a community serving facility as well. The ground and first floors will provide an exhibition center dedicated to Mary Church Terrell and other historical LaDroit Park figures, as well as a social justice resource center. The second and third floors will be our residential programming dedicated to our homeowner. And here we've included another view of the proposed program and plan.
Site programming defines clear boundaries between dwelling and community spaces, keeping the site accessible to the homeowner. Time-controlled lighting, energy-efficient appliances, and ease-of-use technologies will aid in creating a comforting environment for occupants.
There are three main marketable targets our project aims to achieve. Firstly, this model will serve as a precedent for equitable decarbonized housing in the LaDroit Historic Park District and hopefully for all of DC. Secondly, net zero and high performance housing will make living more affordable and sustainable for future generations by reducing utility costs and providing long-term savings via renewable energy certificates, stormwater retention credits, and federal grants. And lastly, in the words of Mary Church Terrell, it is only through the home that a person can become really good and truly great, which is why we will amplify underserved community voices and create equity by providing a social justice resource center in our lower half.
Our integrated systems showcase how we plan to have the Mary Church Terrell House and the system support each other in decarbonization and net zero energy efforts. These will be defined by on-site solar energy capture and storage, our geothermal heat pumping, daylighting and passive HVAC systems, notably natural ventilation, LED lighting and automation, energy efficient appliances, and the insulation of walls, roofing, and floors to control heat gain and loss.
These are the materials we want to incorporate to achieve zero carbon on the site.
Using Vertua concrete eliminates up to 40% of embodied carbon in comparison to industry concrete. We also want to incorporate retrofit interior with eco-friendly materials such as reused pine wood and brick. Reusing the pine wood and brick is beneficial to our site because the reuse of materials eliminates carbon emissions from manufacturing new materials.
To improve the building's durability, we wanted to focus on fire protection and water collection. To prevent future fires, we are improving the fire rating of the roof and firewall. We've also implemented water collection to offset future flooding, recycle water back into the building as gray water, and use it as irrigation in the backyard. We've noted the exterior wall layers to showcase our intentions in controlling heat gain and loss with the hemp wool and waterproofing addition. Natural ventilation from our windows will also help reduce HVAC loads. We've also displayed our electrical plans. The house will be split into 2 zones defined by its programming. Both sections will have LED lighting. The social justice resource section will have occupancy sensors, and the residential section will have lighting controls, both used to reduce the energy usage. We've also implemented solar to generate and feed energy into the building.
This approach is to install a passive heat recovery ventilator with a geothermal pump in order to provide a healthy, comfortable space for the building occupants and increase long-term energy savings. The hedge landscaping works alongside the MVHR to deposit and remove air pollutants, enhancing the outdoor air quality. This low energy consumption system creates an all year round healthy indoor and outdoor environment.
The overarching goal for energy performance is to fully decarbonize the building. We will accomplish this by hitting several main objectives. First is to make the transition from a gas-powered heating and cooling system to electric and install a ground source heat pump. To achieve net zero, the backyard of our site will host a solar photovoltaic array that will produce the required energy for the building. Supplementing the system will be a set of Tesla Powerwall battery packs that will be used to store and redistribute the energy produced on site. These diagrams represent the current energy use breakdown of the building before proposed alterations. These were modeled using Sapphira. The building currently has an EUI of 37, which will be improved after modifications to the building envelope and internal systems.
So going forward, we outline our plans to power us through to final submission as we continue to explore our strategies, collaborate with partners, and conduct analysis. Thank you for listening.
All right, thank you so much, Howard. And now we will get into our Q&A. So 5 minutes, feel free to go through the slides, and I'll pass it off to Stephen first this time.
Good morning, Howard. Great job. Like the presentation. A couple questions. What was the decision, or what went into the decision of making the building multi-use, one residential and then the other community facility exhibition space?
Laura, did you want to touch on it? Okay, Jayla.
So the original use of the building when she occupied it was to fulfill her networking events, but also her strong career in education and community outreach. So definitely for the home to have a steward, we would use the top half because homes that have stewards are better taken care of, but the bottom half will definitely be served to fit the LaDroit Parks area as far as community resources and also Howard University organizations.
Okay.
And in order to fulfill our goal of one of our main strategies of equity, we found it very important to have a piece of our model strive towards that. And by offering social justice resources, we are like amplifying community voices and allowing space for equity to grow.
Okay, and in terms of historic preservation, were there any decisions that conflicted with your sustainability strategies?
Definitely. Speaking as this is a historic house, you know, obviously we can't touch much of the exterior due to law. So we're pretty much working within and renovating the materials we use within rather than exterior.
Okay. All right, Michael.
All right, thank you, Stephen. Hey, good job, guys. Just a couple of questions. So since you are making this a mixed usage, did you think about how you plan on splitting the different systems, so HVAC and so forth? And if you could just talk a little bit about that.
I can speak for the HVAC system. It will be split between the two units. That is something in the finals that we'll be able to provide a better visual graph for.
Okay. And you mentioned geothermal, and since this home is in the DC area, did you look into the ease of geothermal applications? I'm guessing the application you're planning or thinking of is pretty much going underground, correct? Did you
Yes.
look into the feasibility of doing that?
Darian, you want to answer that?
We have not as of now in terms of actual system, like exact geothermal heat pump system, but that's something we will look into further.
Okay. That's all my questions for now, Stephen, if you have any other ones.
Yes. Have you guys considered ADA compliancy with the new building, and how does the design get affected by implementing it?
Definitely. And I'll let Bilal speak on that a little bit too. But since it is such a tight house, it's something that was complicated, but we are speaking to equity overall. And so part of that is applying to ADA regulations and codes. Bilal, I don't know if you want to speak on that a little bit too.
No, I think you covered it. It definitely is something that we're considering and trying to implement, like he said.
And did you guys have an estimate for cost of construction to do these changes?
Yeah, so we did. We came up to a budget of about $186,000. The typical cost for a deep energy retrofit in the area is about $118 per square foot. And thankfully, Howard has already acquired the property, so that also brings our cost per square footage down as well. And then we included a cost analysis for operations, having a social justice resource center, as well as residential.
Okay.
But yeah, totally is about 118,000.
All right. Thanks.
All right. That concludes the 5-minute Q&A. So that is also the end of our presentations for the Retrofit Housing Division. Before you guys all leave, we do want to get a screenshot of the whole group. So whoever feels comfortable turning on their camera can do so. And then we'll just take a screenshot that we can post on our social media platforms and such. So if anyone wants to come on camera and then give a big smile, and I'll remove the spotlights so that we're all equally sized. All right. So, Audrey, you want to do a 1, 2, 3, and we'll all smile for the camera?
I'll do one more. 1, 2, 3.
All right, cool. Thanks for dealing with our awkward photo.
Okay.
Okay, so yeah, that concludes all of the presentations. So you guys are free to jump off and make sure to join our finalist announcements later today.